Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 226 of Leetcode, Palindrome Partitioning 4. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this problem. So this one is a little bit tricky for me just because in Python, this is a very hard problem in Python. I think strategy-wise, and this is just me talking about it, is that I should have just changed, like if I wanted to get a high score, and I could have probably, I should have just changed language to C++ or Java, and that'll be fast enough. And that's what I ultimately end up doing. But I spent a long time trying to get the O of N algorithm to work. And there is an O of N algorithm, and we'll go over it as well. But first, I'm going to go over the N square algorithm that I do, and we'll go over the timing as well. But the N square algorithm is, well, first of all, how do we get an N square algorithm, right? So that we answer the palindrome question, you can find all pairs of palindrome in O of N square time if you pre-calculate it. And this is kind of the way that I did it, recursively with an LRU cache, but basically it's a memorization, which is that given a left and a right, if this is passed left to right, then we return true. And otherwise, we return whether the endpoints are the same. If the endpoints are the same, you look at one more inside. So that this just checks that whether let me write it out. This checks whether left to right is a palindrome. And I usually do this in a different order, but kind of to go over complexity a little bit. Well, left could be from 0 to n, right could be from 0 to n. Why did I use O instead of 0? So that means that the number of possible inputs are n square, and because we do O of 1 work here, there's a time and space complexity, right? And then from that, we have that, then we're able to kind of do this depth first search brute force. It's basically, okay, index goes from 0 to n, parts goes from 0 to 3. So obviously this is going to be actually O of n, because oh snap, actually now, because of this for loop, it actually will be so there's O of n states. Each state takes O of n square work. Is there a linear time algorithm? Now that I'm thinking about it, maybe not. No, there is a linear time algorithm, I think, but maybe not. Actually, maybe I'm wrong, but there's definitely an optimization, and maybe I should have thought about it. But yeah. Anyway, this is the end of so. Each state takes O of n times, so in total this is O of n squared time and O of n space, right? And what this does is, it's kind of a path. Like if you think about graph connectivity, it just shows that, okay, so let's say we have some string, and we're going to space it out a little bit. It just means that if this is a palindrome, if this is a palindrome, that means there's a path forming from this space to this space. And here, for example, there's another edge coming from here, all the way to the end, because the DD is a palindrome, and BCB is also a palindrome. So your path will be from here to here to here to here, right? So basically, this function just checks whether there's a path of length 3 going from the beginning state to the beginning of the string to the end of the string. And the way that I did that is, okay, so I brute force, this is the end conditions. If we're able to get to the last state, we check whether the path is 3. If it's so, it's true, not it's false. Otherwise, we use all 3 paths, but we haven't gotten to the end of the string, we also return false. Otherwise, we just check in a brute force kind of way whether, and that this is O of 1 because of the lookup here, but we have an O of n loop, and this actually does O of 1 as we said. So yeah, so basically all this does is check whether from index to I it is a palindrome. If it is a palindrome, then we check whether, you know, the rest of the string, which is I plus 1, can be done in parts plus 1 number of paths left, or after we avoid taking k paths. So let's put some English on this. Basically, good returns true if starting from index there is a path of length parts, technically I guess it's 3 minus parts if you want, or something like that, to the end of the string. So that's kind of like the English way of putting this string. And after that, you know, a lot of people solve this one and you just kick it off from the 0 string and 0 ring, right? So why didn't I, you know, I actually knew how to do this immediately, and in theory I probably could have gotten it in like 5 minutes the most. And if you see me solve previous problems, you know that I'm not bragging about it. It's just that I'm a little bit upset because you know, to look at the time, I actually end up converting this to C#. I might have said Java earlier, but I meant C#. So my correct submission is actually in C#. This is exactly the same code, except for that I do the dynamic programming or the memorization. Yeah, I do the memorization like explicitly on both the is palindrome and it's good. And the annoying thing is, if we look at here, you know, to see the running time, this one's in 264 milliseconds, so I didn't have to worry about it. I later, after the contest, I just kind of see if I could have done it in Python and quick enough, and it took 9.7 seconds. So on one hand, if I had submitted my Python solution, it would have gotten it really quickly, or like I would have gotten the answer very quickly. But on the other hand, my suspicious is kind of true in that like it was very close to timing out, right? Like if there's 1 or 2 more test cases, I think the timeout time is 10 seconds. So it would have timed out. So like it's hard for, and the reason why I think that is because the n is 2000, and less than 2000 is actually a really tight bound in Python. It's really slow. So you have to be really careful. And I definitely was optimistic in the past and kind of in TLEs. So that's why, yeah. So yeah, so the only optimizations that I would do, that you can do, and I was talking about this, is you can actually rewrite this. Let me change this to Python back. You can actually rewrite this, and if you just watch me doing the contest, I actually tried for a bit. You can actually rewrite this function. You could use something called manager's algorithm to construct effectively a variation of this function in linear time, right? And once you do that, you can actually construct the entire graph, and then, you know, do that graph in a very explicit way. Because here you notice that, and maybe I could have cached this actually so that I don't do a full loop, but you can see that I do this loop and this check every time. But you can actually, you know, think about, if you use managers, you can actually create the edges directly and then only use those edges that gets you to the next node. But I think actually now that I think about it, in theory that would still have n squared time here, but it would at least be faster. I think I was worried about, like I said, you know, if your running time is 9.7 seconds, that would have still shaved a lot of time off the clock, and that's why I was going for that route. And I spent a lot of time doing it, but in the end, the quote unquote naive n squared Python actually worked, even though I mostly did it in during the contest. I didn't C# because it took only 260 milliseconds, and I knew that it would be fast enough. So that was a little bit sad in that regard, but in that regards. But yeah, that's all I have. You could watch me solve it live during the contest next. Okay, so that wasn't that bad. Wow, people got it really quickly though, because I mean, it was just a mistake. So okay, non-empty palindromic strings. Okay. Hmm. 2000 is tough. in Python. I have to learn the managers algorithm. Never needed it, but a lot of people know this one. I mean, I feel like if you have managers, it's quick enough, but I don't know managers that well. So then it just becomes I mean, I have to learn it, so it's probably going to take some time. But I think once I learn this, fine. But maybe in Java I could do n square way of doing it as well. Which is annoying because I think this constant is very slow in Python. That's why to do n square. I mean, I have a full hours I could learn it, but I mean, this is just library function. I'm kind of annoyed about it, but okay, let's go. I guess I could do it that way because it's linear anyway, but because you're wondering, I'm just on the Wikipedia page and just try to copy that a little bit. I think the other way is the convention, but that one. N minus 1. I don't remember how to do this. Piece of I. The right size for this, then we set it to minus. I wrote this code before, but can't find my code somewhere. But okay, so that's basically it'll give us the whole element. So let's kind of take a look. And we just return true and false, right? P. Where do I have P? Why do I have P here? Okay, so this 3 means, what does this 3 mean? This 3 means that there's 3 characters here, right? I forget what these means. It's 1, 2, 3, 1, 2, 3. The first one should be true because it's. I feel like there should be a 2 somewhere. Why is this wrong? Or am I just wrong? Am I using the wrong algorithm? Like, I feel like there should be a 2 somewhere here. Am I doing So we look at I. Is 1 on both sides correct? I guess this is a 1 on both sides, so it's 2. But am I indexing right? Okay, so then I think I'm roughly right, but now I just draw the graph on a DP. right though? This feels a little bit off. Let's see. Let's print this a little bit different way. So the left right isn't quite right the way that I'm writing it. It's 0, 0, 1. Why is this 1? Oh. Okay. 0, 3. 1, 2, 3. But why is this 0? Oh, because it doesn't count the thing, so I have to change that. No, because then now they're different. Okay. Let's start this at 1 then. So this B being 1, what does that mean? That means that I added to here, but we started here, right? I have so many off by 1 situations. I have an hour, I have time, even though this is a silly problem. Unless you've done it before, or maybe I'm doing it a dumb way. But why is this only, oh, this is 3 because it goes here. So actually, maybe I just do this. I'll be okay. And it gets out on the right, which is, this B is 1. Gets out here. Is that right? No, that will always be a little bit awkward. Maybe. Let's look at another one actually. So I don't want the shortest path, so I think this is a little bit awkward. But that's not that bad, actually. So okay, so 0, 0, this is 1, connecting this to this. This one. And I'm just having a lot of off by 1 issues that I'm struggling to figure out how to deal with this manage. I mean, I have the idea, but this is what is 0? What does 0 mean? 0 means if length is 0, it goes to this +1 maybe? I'm struggling to figure out how to handle this a little bit. So this 1 means that this is covered. I think what I have to figure out is So centered mod 2 is 1. That means we're on a character. That means we're on a real character. Then we do then we know that edges of left, even if it's 0, we append that to right. If it's 0, if it's what does that mean if it's 1? Well, it's triggered only because of the first instance. Because I'm dumb about it. I mean, once you set the graph, everything becomes easy because it's just that first search, but I don't know how to set up the graph. But I'm being dumb about it. So here is 1, 2. That's because it includes these silly characters. Actually, let's see. It should be this 2. And now maybe that's better. Yeah, okay. Maybe that's better. So 0, well, -1 is a popular place to hang out. That's not good. Oh, maybe I just been confused the entire time, but yeah, that actually doesn't make sense the other way. Okay. So now you have let's now make this a set. Okay, so now from 0 it goes to itself, goes to 1, goes to 2, 1 it goes to 2, 2 it goes to 3. I don't even know where 3, I guess it's just the last character. That's fine, maybe. Okay, let's see. 0 goes to 0, that's fine. B goes to 1, which is itself, 2, which is B and C, which doesn't make sense. And then 4, which is 1, 2, 3. So 4 kind of makes sense. The 2 doesn't make sense though. The 2 and 2 makes sense. 3. I'm just having the off by 1 issues. Yeah. I don't quite know how to deal with it because I'm not that familiar with the managers. But this looks more reasonable at least, because 0, 0, yeah, I mean. At 40 minutes up, I get it, but it's still tough. Like B, it goes to from itself to itself, which is fine. C should go from... I think my problem is the even length ones. I think that's where I'm struggling with, where I have the middle one, but then it goes from left to right. So I think I just have to really, if center mod 2 is equal to, so okay, so this is odd, then there's a real character, then edges of left, else, if this is the middle, what is the middle? So this is 1 because it encompasses these things, and what that means is that is something like, maybe, I don't know, I'm a lot tired right now, to be honest. Not sure this is wrong, to be honest, but yeah, real debugger. Okay, so left by 0 0 for this one, that's fine. 0 0 for this one, that's fine. No, that's not. This should be 0 1, that's okay. 0 1's in there. This one tells me that, yeah, there's one length, so the left is 0 and the one is 1. So it should go from 0 to 2. Maybe that's fine. I don't know, maybe this is just what I need. I don't know. 0 to 1 to 3 is what I want. 1 to 3 is, I mean, this last character doesn't matter. So, but 1 2 3, 1 should go to 2 as well. So I think that's the one that's missing. But that's because the maximal, that's why. Because this maximal thing, I don't create all the edges. What am I doing? I should have used another language. I think that probably should have been what I done. Because in Python, I think the constants are too slow. Let's see. I don't know any other language. Okay, so let's just do it naively and square. How do I want to do this? Yes. I should have changed the language a long time ago. Yeah, well. Yeah, maybe I could do this in C# or something. Okay, it doesn't crash, so that's good. I forgot. That might be C++ syntax. Okay, awesome. Okay, so that looks good. And then now we just need another so 1, 2, 3, 4, maybe that's 4. That's not good. I know it was going to run, but I thought it would at least give me a right answer. Okay, so this is good. That's not good that this isn't true though. Ideally, I have more here, but I don't know why this doesn't. Let's see. That's weird. Maybe I won't get it because I'm just too dumb today. Why is the inner loop doesn't go beyond on this one? This P is well. True, so why does that not go on the loop? Huh. This is such a silly problem that I don't know why I'm taking so long, but maybe it's just one of those days. This is true all the way, so the SP function is right, but I don't know, am I calling it well? Index I. Oh no, there it is. There's the 0, 1. 0, 3 even. 0, 2. So why is this giving me force? Dun dun dun. Three is the first part, but no, that's not right. What am I doing wrong? It must be something dumb. Oh, snap. That was something dumb. Okay, true, false. Okay, I can't believe I spent that long debugging this. Okay, let's kind of give it a go. If I don't know if this is fast enough, but let's see. That's I hope that is fast enough. It looks fast. Okay, I mean, this is such. I knew how to do it from the get-go, but I guess I should have switched language because I think n is too slow for n square is too slow for Python, but n square was fast enough for other languages. I could be wrong on that one, on the Python one, but otherwise it is such a dumb problem. I mean, it's a good problem. It's just I don't know why they made the constraint such that it's heavily biased against Python. Yeah, I mean, I don't know where I finished because a lot of people got down because I knew how to do that one immediately. It's just, you know, wow, jeebus. It's just that I don't know. I was trying to figure out how to do it in Python for too long when I should have done it in other languages. Because and even here, I wonder how long I spent on this one, but I probably like I had this algorithm pretty much right off the bat. So if I had implemented it from scratch, maybe I would have been slow, but even 20 minutes would have been way faster than whatever I end up taking. A lot of people got this very quick, so I don't think I would have gotten a good score in either case. But what a silly contest. I mean, and I don't feel that bad because I think I see some good people that are like, you know, like Alex I just saw, and I think it's just, oh wow, he got it in 9 minutes. Actually, I don't. Yeah, maybe there is a way to do it. Maybe n square is fast enough in Python. Maybe I was wrong. Because I think if I could do an n square, then I just wasn't confident about it, but I should have just tried it because there was only a 5-minute penalty. Because instead I spent way too long on Python trying to do it the not a fast enough way. Let me try to solve this or not solve it, just solve it normally, but in Python. So I had this crazy algorithm, but basically what I needed to do was just so I would have done something like this, and this is true actually. I guess it is just return this and that's the is Palindrome, and let's do the one for the other one. Definitely good. Index parts, and it's just what is it? If index is equal to n, if parts is equal to 3, return true. Else return false. If parts equal to 3, return false. And then we just do a for I, and I just spent too long debugging something that wasn't needed to be debugged because I'm dumb. There's no way about it. I don't know, just one of those. I mean, my life's been a little bit weird in general, so maybe it is what it is. Good. Yeah, that's I almost made the same mistake again. That's pretty much it. I should have tried this. I mean, this would have even I think I was too scared about the 5-minute penalties, but maybe I shouldn't. I mean, look at this though. It is actually is a legitimate concern. Let's give it a submit to see if it would have worked. I think it should have time limit exceeded. That's why I don't know. If it works, it would have been way barely. So that's why I didn't do it in Python. But as you can see, oh my god. Well, I don't know. Maybe I should have done it this way then. Yeah, thanks everybody for watching. Let me know what you think about this problem. I didn't do that well on this contest, just based on some things that if you watch the contest video, hopefully you'll see. But yeah, hit the like button again, hit the subscribe button again, join me on Discord again, and hope y'all have a good day. Take care of yourself. If you have the fortune, you know, take care of others, to good health, stay good, stay well, you know, and pass it forward, and, you know, treat people around you well, and to good mental health. And I will see you next problem. Bye bye.